Hello everyone, myself Dr. S.V. Zadav and I welcome you to our new lecture on Basic Science Chemistry. So, we are continuing our Unit 1, that is Chemical Bonding and Catalysis. This is lecture number 2, which will be on Chemical Bond Formation. In this lecture, we will discuss ionic and covalent bond in detail. So, before going further, let's revise what we have learned up to our last lecture. In last lecture, we have seen the types of chemical bond formation. The first type which we have seen is ionic bond. We know that ionic bond is formed by the transfer of electron. The second type of bond is covalent bond, which is formed by the mutual sharing of electrons. The third type of bond is coordinate bond, which is formed by one-sided sharing of electrons, whereas the fourth type of bond is the metallic bond, which is formed by transfer of electrons through the metal lattice. So, one by one we will see in detail the formation of all these four types of bond. So our first bond is ionic bond, which is also known as the electrovalent bond. This ionic bond is formed by the transfer of an electrons. Transfer of an electron means out of the two atoms, one atom will lose the electron, whereas the another atom will gain the electron. The atom which loses the electron will acquire the partial positive charge and it will known as the cation, whereas the atom which gains the electron acquires the negative charge and it is called as anion. So there is formation of cation and anion. Generally, all the metals will act as cation, whereas non-metals will act as the anion. Due to the formation of positive and negative charge, there will be electrostatic force of attraction between the cation and anion, and hence there is a formation of an ionic bond. These ionic bonds are three-dimensional. They can extend in all the directions. Generally, these bonds are strong. Due to the strong bonding, it leads to high melting point and high boiling points of the ionic compound. These ionic compounds are soluble in water, and due to the formation of ions, they are good conductor of electricity. The various examples of ionic or electrovalent compound are sodium fluoride, that is NaF, potassium chloride KCl, table salt, that is NaCl, sodium chloride, CaO, calcium oxide, aluminum chloride, and magnesium chloride. So, in this table I have shown the electronic configuration of some of the atoms from sodium to argon. The first three elements which I have highlighted, that is sodium, magnesium and aluminum, they contain electronic configuration with valence electrons 1, 2 and 3 in their outermost shell. So as they are having less than 4 electrons in their outermost shell, they will generally act as metallic and they will have the tendency to lose the electron. Now the yellow arrow is showing the silicon, which is having 4 electrons in its outermost shell. So it will act as the metalloid. The blue arrow is showing phosphorus, sulfur and chlorine. They are having respectively 5, 6 and 7 electrons in their outermost shell. So these elements will act as the non-metals and they will gain the electrons to form the anions. Finally, look carefully the green arrow which is showing for the argon. Argon is having electronic configuration 288. It means it is having 8 electrons in its outermost shell, hence its octet is complete and it is called as the inert gas. It will not lose or it will not gain the electrons. So we will see the formation of sodium chloride molecule as an example. Sodium chloride, that is NaCl, the common salt we are using, it is formed by a combination of one atom of sodium and one atom of chlorine. Sodium is having atomic number 11 and its electronic configuration will be 281, whereas chlorine, that is symbol is Cl, its atomic number is 17 and its electronic configuration will be 287. Now with the help of electron dot diagram, let us understand in detail the formation of NaCl molecule. So see, the first atom which I have shown is sodium atom. This sodium atom contains 1 electrons in its outermost shell, which is shown by the red arrow. It is having electronic configuration 281. Whereas the chlorine atom is having only 7 electrons in its outermost shell. It means it has the vacancy of 1 electron. So this 1 electron from the outermost shell of sodium atom will be donated to chlorine atom, and now it will become sodium ion and chlorine ion. Sodium ion will called as the cation as it has positive charge, whereas the chlorine ion will called as the anion because it is having the negative charge. Due to the attraction of positive and negative charge, they will attract one another and form the molecule of NaCl. So it is all about the formation of sodium chloride. Let's go further. Now we will see the another example of MgO, that is magnesium oxide. This magnesium oxide is formed by combination of magnesium and oxygen. One atom of magnesium and one atom of oxygen. Magnesium is having electronic configuration 282. Its atomic number is 12. So its electronic configuration will be 282. It means it has 2 electrons in the outermost shell, whereas oxygen is having electronic configuration 26. Its atomic number is 8. So it is having 6 electrons in the outermost shell. So 2 electrons from the magnesium atom will be donated to outermost shell of an oxygen atom. So look carefully. These 2 electrons from the magnesium atom, which is shown by the yellow arrow, they will be now transferred to the oxygen atom, which is shown by the green arrows. So as magnesium has donated 2 electron, it will acquire magnesium plus, it acquires positive plus 2 charge, and as 2 electrons are accepted by the oxygen, it will acquire minus 2 charge. Hence there will be formation of magnesium cation and oxygen anion to form the magnesium oxide. So now next we will move to the formation of covalent bond. In covalent bond formation, there is no exchange of electron. There is mutual sharing of electron. It means both of the atoms which are required in the formation of molecule are donating the same number of electrons for the bond formation. Look at this example. A covalent bond is nothing but it is a chemical bond which results from the sharing of the valence electron. In this diagram you can see that I have shown the electronic configuration of oxygen where 2 outermost electrons are combined to form the common bond, which is known as the covalent bond. These covalent bonds are of 3 types. It may be a single bond. When the 2 atoms are joined by the single covalent bond, it is called as the single bond. If the 2 atoms are joined by 2 single covalent bond, then it is called as the double bond. And when 2 atoms are joined by the 3 covalent bonds, it is said to have triple bond. First, we will see the example of single covalent bond formation. For that, we will take the example of water molecule. We all know that formula of water is H2O. It is a triatomic molecule with two atoms of hydrogen and one atom of oxygen. Look at the diagram. The red dot diagram, it is for oxygen. Oxygen is having atomic number 8. So its electronic configuration will be 2 6. There are 6 electrons in the outermost shell of an oxygen, whereas I have shown 2 white dots for hydrogen. Each hydrogen is having only 1 electrons in its outermost shell. So 1 electron from each hydrogen and 2 electrons from the outermost shell of oxygen, they will be shared to form two single covalent bonds. Look at carefully this diagram. In this second diagram, in center part, I have shown the oxygen atom. Oxygen atom is having electronic configuration 2 6. So out of the 6 valence electrons, 2 electrons which are shown by the red dot will be shared with the 2 single electrons of hydrogen atom, and they will form two single covalent bond to form the water molecule. The next example is chlorine. Chlorine is a diatomic molecule. Its formula is Cl2. There are two atoms of chlorine. Chlorine is having atomic number 17. So its electronic configuration will be 287. Here I have shown two chlorine atoms. Each chlorine atom is having 7 electrons in the outermost shell. So each of the chlorine atom is in search of 1 electron to complete its octet. So both the chlorine atom will share their 1 electron, which I have shown by the red arrow. They will be shared mutually to form the one common bond, and you can see that now chlorine molecule is formed where each chlorine is having the electronic configuration 288. It means its octet is complete. I have shown by the green arrow the bond formation of covalent bond. I have shown by the green arrow. So next, here are some examples of covalent compound formations. I have shown the examples of ammonia, chlorine and water. Now look at carefully where the covalent bonds are formed. See, the regions which we have highlighted, there are the formation of covalent bond. I am showing it again. The region which we are highlighting, that is in water molecule, there are 2 single bond. In ammonia there are 3 single bond, and in chlorine there is 1 single bond to form the covalent compounds of water molecule, ammonia and chlorine respectively. Next, now we will move to the formation of double covalent bond formation, and its example is oxygen. Oxygen gas is always an diatomic. It means two atoms of oxygen will always combine with one another to form one molecule of oxygen with molecular formula O2. Before proceeding further, we should know that atomic number of the oxygen is 8 and its electronic configuration is 2 6. It means it contains 6 electrons in the outermost shell. You can see in this diagram, I have shown 2 oxygen atoms. Each oxygen atom is having 6 electrons in the outermost shell. As each oxygen is requiring 2 electrons to complete its octet, both the oxygen atom will share 2 electrons, which I have shown by the red overlap area. It means there is formation of double bond, as one pair of electron is responsible for one single bond formation. You can see that in the red highlighted area there are two pairs of electrons. It means there will be formation of two single bond, therefore it leads to the formation of O double bond O. The another example of double covalent bond formation is formation of carbon dioxide, that is CO2. CO2 is formed by the combination of one carbon atom and two oxygen atom. There are 4 electrons in the outermost shell of an carbon, whereas each oxygen atom contains 6 electrons in its outermost shell. By the red lines I have shown the combination of or the sharing of electrons from the oxygen and carbon. You can clearly see that there is formation of two double bonds between the atoms of carbon and oxygen. So in the yellow highlighted region you can see that there are in both the regions there are two pairs of electrons, hence there is formation of double covalent bond in the molecule of carbon dioxide. Next we will see the formation of triple covalent bond, and its example is N2. It means nitrogen molecule contain two atoms of nitrogen which are linked to one another by triple bond. Before proceeding further, we should know that atomic number of the nitrogen is 7, so its electronic configuration will be 2 5. It means it contains 5 electrons in the valence shell. Look at the electron dot diagram of nitrogen. The central pink part is the nucleus. In the first shell, that is K shell, there are only 2 electrons, whereas in the outermost shell, which is called as the valence electron, there are 5 electrons. So as there are 5 electrons in the outermost shell of a nitrogen, it will require 3 electrons to complete its octet. Look at this diagram where I have shown 2 nitrogen atoms. Each nitrogen atom is having 5 electrons in its outermost shell. Out of these 5 electrons, 3 electrons of one nitrogen atom will combine with 3 electrons of another nitrogen atom to form triple bond between them, and hence it will form the nitrogen molecule with the structure as N triple bond N. So it is all about triple bond formation in nitrogen molecule. Now we will see another example of triple bond formation with an example of acetylene. Acetylene is having the formula of C2H2. Atomic number of carbon is 6, so its electronic configuration will be 2 4. Atomic number of hydrogen is 1, so its electronic configuration is only 1. It means we can say that there are 4 electrons in the valence shell of carbon and there is 1 electron in the valence shell of hydrogen. Look at this diagram. The blue circles representing the carbon, whereas the small pink circles representing the hydrogen. You can see that in the center red highlighted area, you can see that there are 3 pairs of electrons combining with one another to form triple bond between 2 carbon atoms, whereas in the side part 1 electron from carbon and 1 electron from hydrogen will shared with one another to form 2 single bonds between the carbon and hydrogen to form the formation of acetylene molecule. So finally the properties of covalent bonds are Covalent bond is formed when two or more atoms bond together covalently due to the formation of covalent bonds. Generally, these compounds are having the low melting point and low boiling point. Most of the covalent compounds are exist as gases and they vaporize readily at the room temperature. These covalent bonds do not conduct electricity in water, and when they are in the solid state they are very soft and they are non-conductors of electricity. So this is all about formation of ionic bond and covalent bond. So thank you very much for your patience. I hope you are understanding the lecture. If you have any queries, any doubts, please mention in the comment section. If you are comfortable with all the English language which is used in this lecture, please mention accordingly in the comments. If somebody wants that I should use Marathi as well as English language, that also you can mention, and I will share you the link for attendance as well as feedback session of this particular lecture. Thank you very much. Stay tuned for our next lecture. Thank you.